Hello my dear students, welcome back to my channel. Today I am coming with second part of case study based questions of chapter 1 electric charges and field. In part 1, I already discussed about case study based questions based on Coulomb's law and electric field lines. In this part also, I will discuss case study based questions based on electric dipole, electric field lines and electric flux. And if it is required, then I will make third part of this case study based question also, right? But I want to cover each and every topic of this chapter. But before watching this video, you must go through one short revision of this chapter which is available on my channel, and link is given in the description box so that it becomes easy to understand this part, right? Okay, let us start. First case study based question of today's lecture, that is based on electric dipole. Okay. Now, third case study based question is based on electric dipole. Two case based study already discussed in part 1 and this is third one. You know what is electric dipole? It is written here that system of charges forms an electric dipole if, condition is this one, if algebraic sum of its charges is 0 and the center of positive charges do not coincide with center of negative charges. It means suppose there are two charges minus q and plus q and sum of these two charges is what? Net charge is 0 and the center of these two charges do not coincide. These are separated by some distance, suppose twice here. Then this forms electric dipole. And if it is separated by some distance, then there is one term dipole moment which is defined as total positive or negative charges. Total positive charge is also q, total negative charge is also q, multiplied by the distance between the center of positive and negative charges. Suppose distance between these two charges is twice a. So dipole moment P is equal to product of charges and distance between the two charges. It means q into 2a. This is dipole moment and it is a vector quantity. And it is also given that is directed from center of negative charges to center of positive charges. Its direction is from negative to positive, right? This is direction of dipole moment. When this dipole is placed in a uniform electric field, it experiences some torque and that torque is given by P cross E, right? This torque is also a vector quantity and this torque acts on the dipole which tends to align it such that P is in the direction of E, right? It means when dipole is placed in a uniform electric field, what happens? It experiences a torque, right? And this torque tries to align this dipole in the direction of electric field. Dipole moment, suppose minus q is here, plus q is here. Dipole moment is minus q to plus q. So it orients in such a way that it tries to P in the direction of electric field E. So these are given some lines based on electric dipole, right? Now let us start solving some questions based on these electric dipole. Question number 1, okay, right. Now question number 1, in the figure the value of q, find the value of q, here it is find the value of q so that the system is equivalent to an electric dipole should be. Here diagram is drawn here. This one is plus q, this one is also plus q and this you don't know. This capital Q you have to find what is the value of this capital Q so that this system is equivalent to an electric dipole. First pause the video and try to solve the question, right? I am going to solve this one, you also try. So you know, in case of dipole, net charge on a system is 0. Here what are different charges? Plus q, then again plus q, then again this capital Q you don't know, just you write q. You have to find the value of q equal to 0. Total charge is this one. So twice q plus q equal to 0 and from here you get q equal to minus 2q. It means the value of this third charge q is what? Minus 2q. So which option is correct? Option number C is correct, minus 2q. In this way you solve this question, right? Hope it's clear to you. Next question number 2. Question number 2 is with Q as determined above, how much you get the value of Q? Q is equal to, in question number 1, minus 2Q, right? The dipole moment of the system. Now you know at point A plus Q charge, at point B plus Q charge, and at point O here minus 2Q charge, right? Now you have to find dipole moment of the system. You know dipole moment is what? P is equal to product of either of the charges and distance between the two charges. Let it be A here, right? So if the distance between these two charges here minus 2Q, so 1 minus Q at point O and plus Q at point A forms dipole moment P1. Here it is P1, and P1 is given by how much? Q into distance you take A. Again here minus Q at O and plus Q at B here forms a dipole moment P2. What is P2? P2 is Q into A again. So one dipole moment is along this direction, another dipole moment is along this one, right? Now P1 and P2. You have to find the net dipole moment. So angle between these two dipole moment is 90 degree. So how you find the resultant of these two dipole moment? Resultant dipole moment P is under root P1 square plus P2 square plus 2 P1 P2 cos theta, and cos theta is what? 90 degree. It means you know cos 90 is 0. So net dipole moment becomes under root P1 square plus P2 square. Right now? So what is P1 square? P1 square is Q square A square. And what is P2 square? Q square A square again. So this is equal to under root twice Q square A square. So Q square A square you take common. You take outside this square it becomes QA, and inside the under root 2 is here. So QA under root 2. So which option is correct from the first four? A, B, C, D? Yes, D option is correct. I think you get this answer. Under root 2 Q into A. This is the correct answer for this question number 1. You have to find the net dipole moment of the system. So you find first P1, then P2, and then you have to find the resultant dipole moment, right? Hope it's clear to all of you. Next question number 3. Question number 3 is the unit of dipole moment. You know dipole moment is what? P equal to Q into distance between the two charges, Q into A. And what is the unit of this dipole moment? Q is coulomb and A is in meter. So coulomb meter is the unit of dipole moment. Option number 1 is correct, right? Now after this, next question number 4. Yes, it's given that the net force on the electric dipole of dipole moment P is in uniform electric field, right? You know this is a uniform electric field and dipole is placed in a uniform electric field. Dipole means plus minus Q and plus Q. So due to this, when it is placed in a uniform electric field, both these charges experience some force. Force on plus Q charge is in this direction, right? And force on minus Q charge in this direction, so that it experiences some torque because line of axis is different. But net force is what? Force due to plus Q is in this direction and minus Q it is in this direction, and magnitude is same. So net force is always 0. Which option is correct? Option number D is correct, right? Next, question number 5. Question number 5, it is given that, yes, the value of torque on dipole when P and E are perpendicular to each other. You know, tau is what? P cross E. It means P E sine theta. So the value of torque on electric dipole when P and E are perpendicular. Perpendicular means theta, how much? 90 degree. And 90 degree means P E sine 90 is 1. So only P. Which option is correct? Yes, option number D is correct. P E is correct answer. Right? Torque is maximum when P and E are perpendicular to each other. That is P into E. So in this way you solve this first case study based question of today's video. Next, case study, take lines of force. What is this electric intensity? Okay, first you must know about electric field. The region around any charge is called electric field, and if any charge is placed or enters in that electric field, it experiences some force. So electric field is measured by a quantity called electric intensity, and its formula is given by force per unit charge. Electric field intensity is given by force per unit test charge, right? How much force experienced by this test charge is called electric field intensity. So what is written here? First read it. Qualitatively, the electric field at a place, any place you want to find the how much electric field is present. So at a place is described by presence of electric lines of force. If you observe the electric lines of force, and with the help of that electric lines of force, you can easily find electric field at that point, right? How you find with the help of electric field lines? The crowding of these lines indicate more intense electric field. Crowding means what? Closeness of the field lines. Suppose this is charge plus Q, and due to plus Q charge, the electric field lines begins from this positive charge, right? Like this one. Electric field lines are drawn like this one, right? And the relative closeness of these field lines at the near the charge, the field lines are very close to each other. It means here electric field intensity is more. So the crowding of these lines indicate more intense electric field, and direction of electric field at a point is tangential to the field lines passing through that point. Suppose this is electric field lines. So if you want to find the direction of electric field at this point, you just draw one tangent. This gives direction of electric field at these points on the electric field lines, right? To indicate the strength of electric field, we use the word electric field intensity, that is capital E. Mathematically, the electric field intensity at a point is defined as a ratio of force acting on a test charge Q naught placed at that point. It means F by Q naught. And why it is written here limit Q naught tends to 0? Because the value of this test charge is very, very small, so that it does not affect the presence of electric field due to the source charge, right? That's why here written limit Q naught tends to 0. And also you know there are different properties of electric field lines, like two electric field lines never cross each other. These are two electric field lines, right? First one and second one. These two never intersect each other. Why? Because at the point of intersection, there are two tangents can be drawn to represent direction of electric field. One is on this one, another tangent is on this one, E1, and here E2. At the same point of intersection, there are two directions of electric field, which is not possible. That's why there is most important property of electric field lines, that two field lines never intersect each other. Hope it's clear what is written in this paragraph about electric intensity and electric lines of force. Now let us start solving question. Okay. First question is, right, it's very simple. Try to solve it, pause the video and solve this question. The electric lines of force, right? Wait, it's not visible. Okay. Now it's clear? Yes. The electric lines of force, first option is real lines, imaginary lines, closed lines, and none of these. Which option is correct? Electric field lines are real lines? No. These are imaginary lines? Yes, this option is correct. Closed lines? No. Electric field lines never form closed loop. It starts from positive charge and ends at negative charge, right? Like this one. It never forms closed loop, that is from minus Q to plus Q. So this option is also wrong, and none of this is. So correct option is option number B, imaginary lines. Electric field lines of force are imaginary lines, right? Now next question number 2. Yes, this one is, okay. At point A, the electric lines of force are N1 per unit area and N2 at place B, right? At point A, suppose this one and this one is point B. At point A, the electric lines of force are given N1 per unit area. In a particular area at point A, number of field lines are N1. Here, number of field lines at this particular area is N2. So N1 and N2 are number of field lines at point A and B. And it is given that N1 is greater than N2. number of field lines at point A is greater than number of field lines at point B. So greater the field lines, greater the intensity at that point, right now. So you have to find which option is correct. First one, electric field is more intense at A. Yes. Why? Because N1 is greater than N2. At point A, N1 number of field lines, and at point B, N2, and N1 is greater than N2. Number of field lines at point A is more, so it means electric field is more intense at this point. So first option is correct, but still you must read other options also. B, electric field is more intense at B. No, it is less intense. Electric fields at A and B cannot be compared. No, it can be compared. Data is insufficient. No, so all other options are incorrect. Only first option A is correct. Right? Now, next question number 2. Next question number, 3. Yes. Question number 3 is, two electric lines of force can intersect, cannot intersect, intersect in some special conditions, none of these. Which option is correct? I already discussed about electric lines of force. Yes. Try to solve it. It can intersect. No. Two electric lines of force, suppose this one is first electric lines of force, this one is second electric lines of force. These two lines of force never intersect each other, cannot intersect. Why? Because at the point of intersection, it gives two direction of electric field. You draw one tangent through this point on first curve and again at tangent on this second curve. So it gives E1 and it gives E2. At the same point of intersection, there are two directions of electric field, which is not possible. That's why two electric lines of force cannot intersect each other. Hope it's clear to all of you right now. Next, question number 4. It is given that limit Q0 tends to 0 has been taken due to the reason. I already told you that the charge which experiences some force is always taken as test charge. Its value is very, very small. Limit Q0 tends to 0. Why? Yes. Let us read all the options. First one is, Q0 must be so small that it may not affect the original field. Okay, read other options. Q0 must be small so that it may confine in a narrow space. Third one, no restriction on value of Q0. Q0 must be unit charge. Which one is correct option? 1, 2, 3, 4. Yes. Yes. Solve it fast. Yes, very good. Option number A is correct. Why Q0 is small? Q0 must be so small so that it may not affect the original field. There is a source charge Q and there is electric field around this charge. So if you find the electric field at this point, you place one test charge Q0, which is very, very small. And how much force it experienced by this test charge, it gives electric field at that point. So this test charge must be very, very small so that it does not affect the presence of electric field due to this original field, right? So option number A is correct. Okay. Next, last part, last question of this paragraph. Yes, question number 5. It is given that which of the following is not the unit of electric intensity? You know electric field. Electric field is what? E equal to F by Q, right now. So what is the unit of electric field here? One unit is force is Newton, charge is Coulomb, Newton Coulomb. This is correct option, Newton per Coulomb. So this one is correct option. Right now here question is which of the following is not the unit of electric intensity. Right. Second one, joule per meter per Coulomb. It's right or wrong? Yes, it's also correct. Why? Force is what? Force is work done. Work done is force into distance, right now. So force you can write work done by distance. Newton is what? Here Newton is joule per meter. So you can write in place of Newton joule per meter Coulomb. It becomes joule per meter per Coulomb inverse. So second option is also correct right now. Third one, volt per meter. Yes. E equal to dV by dl. You already studied about this equation right now. E equal to dV by dl. This is change in potential difference. It is in volt and distance is meter. So volt per meter is also unit of electric field. Now fourth one, joule per coulomb. No, joule per meter per coulomb. This option is correct. This one is wrong. So here question is, which of the following is not the unit of electric field density? Option number D is correct. Right? Joule per coulomb is not unit of electric intensity. In this way, you solve this second case study based question. Right? Now, one more case study based question based on electric flux. Okay. Now, last case study is based on electric flux and Gauss law. What do we mean by this electric flux? Okay, what is written here? Electric flux through an area is defined as EA. Physically, meaning is electric flux is nothing but, suppose there is an irregular surface, right? And through this area, how many number of field lines passing, right? So, electric flux is defined as number of field lines passing perpendicularly or normally through this area, and its symbol is phi, and phi is given by, mathematically it is written here that electric flux area is defined as E dot A. E dot A. E is electric field, A is area vector, and area vector is always perpendicular to area. If both electric field and area vector are in the same direction, it means what? Phi is equal to EA cos theta, and same direction means theta is 0. So EA, maximum flux is there when both electric field and area vector are in the same direction. And area vector is always normal to this area, right? Suppose this is a plane and area of this plane is this one, right? This is area of this plane and area vector is perpendicular to this plane. Suppose area vector is this one, right? A. An electric field line is also passing through this direction. So both are in the same direction. In this case, maximum flux is there. This is electric flux, right? Now, after that, Gauss law is used to assess amount of enclosed charge. Actually, what is Gauss law? Gauss law, according to this theorem, total flux through any closed surface. Suppose this is a closed surface. So how much number of field lines passing through this closed surface? That is total flux through any closed surface. It is written for closed surface, flux is written E dot ds, right? So total flux through any closed surface with phi equal to integration of E dot ds is given by Q by epsilon naught. Q means Q inside. How much charge enclosed within this surface divided by epsilon naught. If you know amount of charge within any closed surface, you can easily find total flux through this closed surface, right? Using Gauss theorem. So here it is written, the concept of flux and Gauss law is very helpful in case of non-polar area, means irregular shape of the body, circulation of flux where it is not easy to find flux. Gauss law is also very important to calculate electrostatic field. With the help of this Gauss theorem, phi equal to E dot ds equal to 1 by epsilon naught times total charge enclosed within the closed surface. This Gauss theorem is very helpful in calculating electric field, right? Total flux through any irregular surface. Both these two can be easily found with the help of this Gauss theorem. Flux due to change is additive in nature, right? Gauss law is not dependent on shape. Suppose, okay, wait. Suppose there is a cubical body, right? This is a cubical body and total charge enclosed within this body is Q. And suppose there is a sphere. Inside the sphere, total charge is Q. So, according to Gauss theorem, total flux in both cases is what? Q by epsilon naught. And Q is same in both the cases, right now? In both enclosed surface, total charge is Q. It means total flux is same whether it is charge is enclosed within the Q or total charge is enclosed within the sphere. It means Gauss law is not dependent on the shape and size of the body. So this is about electric flux and Gauss law. Now let us solve some questions based on these topics. Good. Okay. Now question number 1 is, Gauss law is dependent on internal charge configuration. Suppose this is a closed surface and in the closed surface one charge is present at this point, another charge is present at this point, third charge is present at this point, Q1, Q2, Q3. Only it is important that how much total charge enclosed by this closed surface. It is not dependent on internal charge configuration. When you apply Gauss law, in case of Gauss law, it is dependent on internal charge configuration. Yes or no? Inside the closed surface, at any point this charge lies. It is not important that what is the configuration of internal charge, right? Only total charge is required. According to Gauss law, E dot ds surface integral is equal to total charge Q inside by epsilon naught. So, which option is correct? First one is no, it's not. Second, yes, it depends on charge configuration. Third, maybe, and fourth one is both A and B. Hope you have guessed the answer. Yes, option number 1 is correct. No, it is not dependent on internal charge configuration. Only total charge inside the closed surface is important. Okay. Now next question number 2. Question number 2 is it necessary condition to have symmetric surface for Gauss law application? Suppose there is one charge here, another charge here. To apply Gauss law, you have to draw one Gaussian surface, right now? So here question is it necessary condition to have symmetric surface for Gauss law application? Yes, the surface which encloses this charge must be symmetric and electric field is constant on that surface. The surface must be symmetric. Which option is correct? Yes, no, maybe, depends on situation. Yes. It is necessary condition to have symmetric surface for Gauss law application, right? It's very easy. This paragraph is very easy and all questions are also very easy. Now question number 3. What is this question? It is given that electric flux through a closed surface is due to total charge enclosed, total charge present on the surface, total charge induced on surface, all of the above. Which option is correct? Yes. Electric flux through a closed surface depends on which one? Which option is correct? You know Gauss law, right? Yes. It only depends on how much charge enclosed by the total surface. Here, electric flux through a closed surface is due to, first option is total charge enclosed. Second one is total charge present on the surface. This is a closed surface, a charge is present inside this closed surface, right? Q1, Q2. So, electric flux through a closed surface depend on due to total charge enclosed, total charge present on the surface, total charge induced on surface, all of the above. Only total charge enclosed. First option is correct, right? It only depends upon how much charge enclosed by the total surface, right? Now, question number 4. Yes. It's not visible. Wait. Yes. Now it's visible. Yes. Question is, the Gaussian surface should not be passed through any discrete charge because when you want to find electric field due to any closed surface, you have to draw, suppose charge is present here, Q1, Q2, you draw one Gaussian surface. This closed surface is called Gaussian surface. Now, how you draw this Gaussian surface? The Gaussian surface should not be passed through any discrete charge. Number of charges are present inside this surface. You have to draw a Gaussian surface so that it does not pass through any discrete charge, because electric field becomes 0, electric field remains constant, electric field due to a system of discrete charge is not well defined at location at any charge, electric field is continuous charge distribution. Which option is correct? When you draw Gaussian surface, it does not pass through any discrete charge. Why? Yes, which option is correct? Option number C. Electric field due to a system of discrete charge is not well defined at location at any charge. Hope it's clear to all of you. Now last question number 5 of this part. Yes, question is, what will be flux of a box with no charge in it? Suppose there is a box of any shape, cube or spherical, any shape, and there is no charge present inside the box. So what will be the flux? Flux will be Q by U naught, flux will be 0, flux depends on symmetry, not sufficient information. You have to find flux. You know, according to Gauss theorem, flux is what? E dot ds equal to q by epsilon naught. If q is 0, no charge enclosed inside the box. Box may be of any shape. It is independent of shape and size. Flux only depends on total charge enclosed within this surface. So if total charge is 0, it means flux is also 0. Which option is correct? Yes, very good. Option number B is correct. Flux will be 0. In this way, you solve all these questions. Right? So I had discussed 3 case study based question today, right now, and 2 in the previous video. So total 5 case study we had discussed, and in part 3 I will discuss 2 more case study based on Gauss law and its application, so that I will cover all topics of chapter 1, right? At any point, any case study may come in exams. So students, if you want this type of videos, please write in the comment box, and also must like, share and subscribe, okay, so that I will make more videos for you. Up to then students, keep revising and stay tuned with this channel. Thank you.